Assalamu alaikum, dear professor and students. Today I am going to discuss the differentiation of trigonometric functions. So first of all, before starting, we should know what a differentiation is. So I'll just write that down. So differentiation rate of change of this is normally a dependent variable. Rate of change of a dependent variable when there is a change in, and normally this tends to be an independent variable inside a function. So basically we do know that inside a function there are two variables. So when one variable changes, what is the rate of change of the other variable? So rate of change of a dependent variable when there is a change in an independent variable inside a function. We will just add that, inside a function. So basically there are three types of differentiation. I'll write that down as well. So the first one is the algebraic. Yeah, there you go. Algebraic. Second one is the exponential one. And the third one, which we are going to discuss today, is the trigonometric one, or trigonometric one. Now, as I said that we will discuss the trigonometric differentiation of trigonometric functions. So we'll go to the next page, and there are 6 trigonometric functions, and all of them have a derivative. Even their inverse does, but we won't discuss the inverse derivative, the derivative of the inverse functions. We'll just discuss the 6 basic ones, and I'll just write down trigonometric derivatives. Yeah, so basically trigonometric derivatives, there are total of 6, and the first one is d upon dx sine x equals to cos x. I'll prove this one using a graph, and I'll also prove this one, d upon dx cos x equals to minus sine x. Then the third one that comes up is d upon dx tan x equals to sec square x. These, as we all know, these three are the main trigonometric functions, but then these also have the 1 upon versions. So 1 upon cosec, 1 upon sine x, correction. So we all know that that is cosec x, which equals to minus cosec x times cot x. Then we come to the fifth one, which is d upon dx, and the inverse of cos, which is sec x, and that is sec x times tan x. Then we come to the sixth one, which is d upon dx, the inverse of tan, which is cot x equals to minus cosec square x. So these are the 6 trigonometric functions: sine x, cos x, tan x, cosec x, sec x, and cot x, and these are the derivatives of them. So I'll prove to you sine x, why sine x equals to cos x, and cos x, and why cos x equals to minus sine x. But before I move on proving why sine x equals to cos x and why cos x equals to minus sine x, I would like to tell some tips on how to remember these trigonometric derivatives. So first of all, as you can see, all of the co-functions, so cos x cosec x and cot x. So the co-functions, they have a negative sign with them. I'll use another color. So negative, negative and negative sign. Another really interesting way to remember the trigonometric derivatives is that notice how tan x has the derivative of sec square x, while the 1 upon tan or cot x has the derivative of cosec x square and just a negative with it. So basically we all know that sec x square is 1 upon cos square x, while cosec square x is 1 upon sine square x. So basically all we have to remember is that if it's a tan, it is 1 upon cos square x, positive 1 upon cos square x, and if it's a cotan, then it is a negative 1 upon sine square x. Also another thing is that sec x and cosec x have the sort of same pattern going on as well. So basically cosec, because it's a cos, so we know it's a negative, and cosec's derivative is cosec itself, and then we just add a cot to it, meaning a 1 upon tan x. And with sec x, again the derivative is sec x itself, and because it's not a co-function, there is a positive, and we just multiply it by tan x. So these are some of the ways trigonometric derivatives can be easily learned. These are some of the, basically you could say, hacks to learn the trigonometric derivatives, but it's obviously better to know the logic behind it, and I'm going to show you the how I'm going to show you a graph on how sine x, the derivative of sine x equals to cos x, and how the derivative of cos x equals to minus sine x, and the rest you can do it by yourself and see by yourself. So here is proof that derivative of sine x is cos x. Basically what it is that we do know, I think I'll use a pencil, that would be better. So here's the graph of sine x, here's the y-axis, here's the x-axis, here's the limit of the y-axis from y is more than negative 1 and is less than or equal to 1, and the x-axis, the limits are 0 to 2 pi. And so basically over here we can see that over here is the dy upon dx and x-axis. So basically over here we can see that the gradient is the line is straight, the slope is straight here, so the gradient over here is 0, and over here as well the gradient is 0. So at pi upon 2 the gradient is 0, so we will mark it over here, and at 3 pi upon 2 the gradient is 0, so we'll mark it over here. So now basically over here there is an estimate that m equals to 1, and because it's going upwards, that's the reason the value is positive 1. So because mathematicians have made this sort of estimation, we will use that estimation to our advantage. So dy upon dx over here, or m equals to 1. So basically, as I said before, differentiation is the rate of change. So basically dy upon dx or is the gradient, or the differentiation is the gradient. Differentiation of any function is actually the gradient of a function, in other words. So that's why we are finding out the gradient over here. So now going ahead, at pi, the from pi upon 2 to 3 pi upon 2, the slope is going downwards, and because we have estimated that the gradient is 1, so m at pi equals to minus 1. At pi m equals to minus 1. So we'll mark it over here. 1 minute. Here we go. And now again at 3 pi upon 2 the gradient is 0, and then going back up at 2 pi the gradient is back to 1. So here we go. Now all we need to do is join this. missed the spot there sort of. And it's not a perfect graph, but you get what what I am trying to make. And as we all know that this is a cos graph, that's why the gradient of sine x is cos x. So as I said that I'll also prove that derivative of cos x is sin x. So I've drawn the graph of cos x. I've not mentioned the limits because I didn't mention it previously. So basically the limits are that y is more than minus 1 but less than equal, more than equal to minus 1 and less than equal to 1, while x is from 0 to 2 pi. So here I'll demonstrate to you why the derivative of cos x is minus sin x, correction, not sin x. First of all, I'll change this minus sin x, and now as I said, I'll demonstrate it to you. Again, I'll use a pencil. So basically over here again the slope is straight, so the gradient over here is 0. Again the slope over here is straight and straight here as well at pi and 2 pi, so gradient again is 0. So we have marked these 3 points. Now going down again, the mathematicians have estimated that the gradient of the slopes of any trigonometric function graph is always 1 unless going downwards, so it is a negative 1, not a positive 1. So we'll go down, pi upon 2 is negative 1, and then we come back up. We are going down, then comes pi, and then we go back up. So over here the gradient is 1, and if we draw this, it will come over here, and then it comes back to 0. So now we'll draw the graph. So here's 0, and then here's the top point, and then we come back to 0. As you can see, this is a sine graph, except it is the inverse or the reflection of a sine graph. So that is why minus sine x, and here it is cos x. So the derivative of cos x is minus sine x, as I have proven over here. So thank you for watching. This video was presented to Dr. Abdul Hannan Shaikh, and thank you Dr. Abdul Hannan Shaikh for watching my video, and the viewers as well for watching my video. That is it from me today. See you next time.